Welcome back to the channel, guys. This is your physics buddy. In the previous sessions, we started work, energy, and power. In this lecture, we are going to talk about work-energy theorem. We'll define some conservative and non-conservative forces, as well as we'll try to calculate the power as well. Apart from this channel has already covered different units of AP physics as well as honors physics. Do check them out. Do devote some time in order to acquire knowledge. Make sure you subscribe to your physics buddy and hit the notification bell to follow the entire series. Stay tuned and let's do that.
So let's just continue where we left in the last class.
Yeah.
We talked about kinetic energy first, and then we moved to the potential energy. I explained this thing that whenever we are calculating potential energy or any other kind of energy, or you can say whenever we are calculating any kind of work, either force should be in the direction of displacement or displacement should be in the direction of force. That was the key condition. So here also, when we are describing potential energy, we will say that energy which is associated with the configuration of the body, or you can say which is associated with the position of the body, or you can say which changes with the position of object. That energy is something called potential energy. So here I just gave an idea that assume that there is an object which is placed at a theta inclination surface. We just displaced the object through some displacement along the inclination, along the inclined plane, such that vertically it moves h height. So in that case, if we try to calculate the work, this work is going to be Fs cos theta as per its basic definition. And when we solve it, we'll get work as negative mgh. So this negative mgh is actually representing that work is done against the gravity. We are moving it up the incline. And the same thing is going with the incline, or you can say if something is dropped from a certain height, then work done is going to be in the direction of force. That is, we can say that here work done is so in the first case, you can say work is done against the external force, against the applied force, or against the gravitational force, and here work done is in the direction of gravitational force. So this direction thing, or whether this work is going to be positive or negative, this can be asked. Work done by the force, or you can say work done by the gravitational force in the direction of displacement. That side is positive. So this is what I was writing here. In case 1, work is negative because force and displacement are in opposite direction. Similarly, if we discuss the second case, we'll simply say work is positive because force and displacement are in same direction. So this is what we can say about potential energy. Like these are the things, this is the type of energy that we need to understand before actually talking about another form of energy. Let's just talk about few other things as well. Then we'll move to different types of potential energy. Yeah. So I just told you that once we're done with this kinetic energy and a little bit of potential energy, we'll talk about work energy theorem. So let's talk about this work energy theorem once, and then we'll move to different forms of potential energy. So if you remember, I just let you know that work energy theorem is something which is help us to calculate any change in kinetic energy of any system if that system is experiencing some external force. So today we are going to learn that how this work energy theorem is given. Like it's a very basic thing. First of all, we need to understand that what exactly is happening here. Suppose there was an object and that object was initially moving with some velocity. So I can assume that its initial velocity is some vi. Suddenly, some force from the backside, or you can say from the backward direction, starts acting on the given mass. Now we already know this thing. What will happen to it? This object will experience change in its velocity because of the acceleration. So we can say here that the final velocity of the object, once we observed it, has changed to some v final. During that period, it must have done some displacement. There must be some change in its energy, and so on. So here, what we can say is, if we try to calculate the work done by this external force on this moving body, so we know work is nothing but force times displacement. Again, force can be written as mass times acceleration. We already talked about this thing that in place of as, that is acceleration times displacement, we can write from third equation of motion. So here, work can be written as m v final square minus v initial square by 2. From where we got this? We got this from second equation of third equation of motion from kinematics. Once we move the equations a bit, we're going to have work done on any object experiencing some external force as change in its kinetic energy produced. So
Mhm.
what this theorem says is, to be precise, that if some object experiences some force and that force is capable of doing some work, so we can simply say that this force must have changed its kinetic energy. And this is the proof, or you can say this is something we can say work-energy theorem. So we can simply write this states when an external force acts on a body, whatever change in its kinetic energy is going to be observed, it must be equals to work done by this external force. So to understand the application part, let us take few problems on this. Then we'll move to the next section.
Mhm.
Did you try any question from the assignment?
Yeah. I did like 3/4 of the first one I sent, and then I didn't. The other one's due tomorrow.
I am talking about the one which you shared earlier.
Yeah, yeah. Yeah, those are two different assignments. The first two screenshots are one assignment. The second two screenshots is a different assignment.
Okay. So let us just try to solve this problem. So the question says that there was an object. Let me just assume there was a car. This
Mhm.
car was initially moving with 30 kilometers per hour. This car is having a mass of 1400 kgs. It's stuck by some truck which imparted a force of 1200 newtons, because of which the velocity, or you can say the speed of car, changed to 50 kilometers per hour. That was a collision, which you can say it is elastic collision, so there must be no loss in energy due to collision, we can assume final velocity has changed to 50 kilometers per hour. This is also the mechanism. The question is find work done by this force. I can say work done by this collision, the car. So it's a pretty simple question. You can try it out, but again, what you need to understand here is you need to change the things in SI units. So make sure that you change them first.
Okay. Okay, using the formula I got 86,450.
Which formula did you use? This one?
Yeah, the work energy.
All right. Let's check this once. So work done, whatever work is being done here, it must be equals to the change in kinetic energy produced due to that collision. It must be equals to half times 1400 times. Now we have to change this in velocities in meters per second to get the answer in joules. So 50 kilometers per second can be written as 5 into 5 by 18. Like you must know this thing that kilometers per hour is equals to meters per second if it is multiplied by 5 by 18. So we can simply do that. It is going to be 250 over 18. Similarly, 30 into 5 by 18 as well. So this is what you can do to find out the velocities in meters per second. Did you do that or did you just use calculator to get the answer?
It's used. No, I use the theorem. I mean the formula.
Yeah, you used a formula, but the velocity I'm talking about.
Oh, yeah, I see the calculator.
So we have to simply substitute these values. We can reduce them. Let's just keep it till here, like that only. So 250 square minus upon 18 square minus 150 square over 18 square. So you can try solving this equation and you'll get the work done. Let's just get the answer. So 2860. This will give us work done around 86,419.75 joules. You got this?
Mm-hmm.
Is that was yes or no?
Yes.
All right. Another question you can try it out on work energy theorem is, so we can assume that, again I'm taking a simple one. There was an object and that object was initially at rest. Suddenly some force came, or you can say its act on this object such that its velocity increased to 25 meters per second. Mass of the object was given as 5 kgs. You have to find out the work.
1,562.
Yeah, it's correct. So simply again you have to apply the same thing.
Mm-hmm.
You just have to find out the change in kinetic energy, which in this case is going to be this only. So this is something which will be getting as 1575 1575 joules. Initially it was at rest, so initial kinetic energy is going to be 0. Final is going to be half mv square. So half times m times 25 square is 625. Once you solve this, you'll have 1575 joules, I guess. Yeah, so that is what you were supposed to do in these kind of problems here. So let us try to solve out question number 66 from the same worksheet which you shared. Let me just give you the idea. Question number 66 says a 10 kg test rocket. We have given a mass of the rocket which is 10 kgs. Is fired vertically from cap canaveral. Its fuel gives it a kinetic energy of 1960 joules. So the kinetic energy it has is 1960 joules. It is given here. By the time the rocket engine burns all the fuel, what additional height will the rocket rise? So you have to find out the additional rise in its height because of that kinetic energy. Like just think about it. Think about this question.
Okay.
This question is a perfect example of work-energy theorem. Like this is something which we'll learn regarding work-energy theorem. This is what you have to apply again to find out the height. Think how we can do this.
Mhm.
Just think it is in this way that at what height this rocket is going to go if initially it has some kinetic energy, which is 1960 joules. So if it has kinetic energy initially, we can say it must have some initial velocity. Once it reaches its maximum height, whatever velocity it was possessing initially, it must be zero at that point. And what change you will observe? You will observe that it must have gained some height. Think
Mhm.
about it.
Mm. Like, how would you relate that to height? Yeah, it gains, but
Using work done.
oh,
So initially it possessed some 1960 joules of energy. It must have some velocity here. The moment its velocity becomes nothing, or you can say its kinetic energy becomes zero. So during that transition, what would happen? Like which force is acting on the body? What kind of work is being done here? That change in kinetic energy of the system must be equal to the work done. What kind of work done is going to be done here? Think about it.
mm,
Which force did some work here? Think about it.
yes, like what kind of work is being done?
Not what kind of work, but you can say which force actually did some work here.
Like, what part of the rocket, or
During its motion,
yeah,
there must be some force which is mg, which must have done some work. But the displacement was there in the upward direction.
right,
So we can say that work done is nothing but mgh, and cos theta is going to be negative 1, as it is 180 degrees. And change in kinetic energy can be written as final minus initial.
okay,
So final must be 0. Initial is going to be given as 1960. Mass is given as 10 kg, so we can take it as 10 only. G is going to be 9.8. Height is something we have to find. So this height is going to be negative 19.60 over negative 98. So can I say it must have moved,
Mhm.
or you can say raised up to 20 meters of height.
Yeah.
Like this much thing you have to do here. That's it.
All right. Understood.
Yeah. So try out question number 74 as well.
Okay.
The next one. The question says that there is a mass, or you can say there's a rock of 20 kg mass, which was at the cliff. You can say which was at 100 meters height cliff. It was at height 100 meters, we can say. What speed does the rock have as it strikes the ground? You have to find the speed when it strikes the ground. Again, you can use the same work-energy theorem to find out the velocity.
Mhm.
Try it out.
So for this one, you have to use like a different form, MGH, like potential
Yeah,
equals kinetic, basically. Yeah.
change in kinetic. So we can again simply say that using work-energy theorem, work done by this mg, I can say the gravitational force must be equals to the change in kinetic energy, and the work done must be equals to mgh. Change in kinetic energy is going to be final minus initial. Initial must be 0. Why? Because it is supposed to be at the topmost point where it has no velocity. But when we dropped it, because of mg, there must be some work, and that work is going to be mgh. And this work is also going to be positive because forces are acting in the direction of displacement. So v square must be equals to 2gh, or you can say v is equals to root 2gh. So 2 times 10 times 100, which is going to be 20,000 in roots. So you can say 10 root 20 meters per second must be the velocity of the body or the rock once it hits the ground. So that much simple this question was going to begin. Did you got this?
Yeah. I mean, I didn't get it, but I understand.
Okay. Okay. Just try out the next question as well. 76.
Okay.
A 2 kg rock that is initially at rest loses 407 joules of potential energy when falling to the ground. Calculate the kinetic energy of the rock gains while falling. What is the rock speed just before it strikes the ground?
Okay.
So this much velocity is going to be the answer with which it is going to hit the ground.
Mhm.
So that's all. That is what you have to do in this problem.
All right. I see.
So if we talk about lesson 1, we do talk about work, we do talk about energy, we do talk about kinetic energy and work energy theorem. So one more thing that we need to discuss here is power. So let's just talk about power now, like what this power is going to be. So power is something which is defined as rate of doing work. Like with what rate work is going to do or work is going to done. It's something which defines power. So it is something which can be written as work done per unit time. Whenever there is word rate in any definition, it means that we are referring time, that how much time we have consumed to do the same job. So this is something which is defined, which is defining average power. So whenever we are supposed to calculate the average power, it is going to be work done per unit time. Apart from this, we need to understand this unit, the power, as a unit of watt, which is a derived unit. Similarly, it must have unit as well, joules per second. So this is what power is. Now, if we just try to manipulate this relation and see what we can get apart from this work done upon time. So we know work is nothing but force times displacement upon time. So here, as we know, the displacement per unit time is nothing but velocity. The power is also force times velocity. These are the two relations that we'll be using to solve problems related to power. Also, we need to understand that power is a scalar quantity. So it must not have any direction. It will simply define that with what efficiency, or you can say with what speed that whole thing is going to done. So let me just take a very simple question to explain this concept. Suppose there is a crane, and this crane lifts a mass of 1000 kgs to a height of 10 meters in such a way, or you can say in such a way that there were two cranes, crane A and crane B. Crane A does this job in 1 minute, whereas crane B does this job in 2 minutes. Question is, which crane consumed more power to do the same work? Which crane consumed more power to do the same work? Or you can say which delivers more power. So think about it, how we can answer this.
Crane. Actually, both of them did the same amount of work, but I guess Crane A used more power.
Yeah, that's correct. So let me just show you that how you're supposed to write this answer. So first of all, we'll try to calculate power for both the cranes. So here power to crane A is written by work done by this crane in given time. So work done is going to be same, that it is mgh again, but time it is different. It must have taken 1 minute to do the job. So power would be 1000 times 10 times, if I take g as 10, again it is going to be 10. So it is going to be 10 to the power 5 joules of work, whereas this must have done in 60 seconds. So this must watt of energy it must have, you can say this much amount of energy it must have used. Similarly, if we talk about the crane B, it also does the same work but in more time, that is 120 seconds. So we can simply say here that as power is inversely proportional to time, and time for crane A is less than time for crane B, so power consumed for crane A must be more than power consumed for crane B. So this is how you are supposed to answer these questions when it comes to comparison. Always remember, whichever machine takes lesser time to do the same job, done by another machine in more time will consume more power. It is something which is inversely proportional to time, you can say only. A device consuming lesser time to do the same job, it simply means that it must have consumed more power. So this is how you are supposed to think about this power thing.
Okay.
Did any question in the worksheet consist of power related problem? Did you find them?
Find what?
Uh, Power related problem. Okay,
Oh,
so
power.
basically now you should try it out. Question number 7th
7. Okay.
from the first worksheet. It is based upon power only. So question says a 75-watt light bulb is left on for 2 hours. So there's a bulb having power rating 75 watt and it is being operated for 2 hours. Question is how much work is done. You have to find the work done. So again, it's a pretty simple question. You can use the definition of power, that is work done upon time. And using that, you can find out work done easily. But make sure whenever you are solving this equation, time must be in seconds.
Mhm. Wait, did you get this question from the worksheet I sent?
Yeah. Question number 7th.
7th is
Um,
vertical spring launch.
7th from this one. Check it out.
Oh, okay. All right. Mm,
So what's important here is that you convert time in seconds to get the work. 2 hours has 60 minutes. Each minute has 60 seconds. So work done is going to be 150 times, that is 600, which is approximately 54 times 10,000 joules. This is what we have to here.
okay.
Yeah. Apart from this, try that question number 9 as well
Mm.
from the same worksheet. 417.
No, 17.9 kgs.
Okay, let us just quickly check this. So work done, as I said, it is going to be power times time. But here we have to find out the mass of the crane. So work done is going to be mgh here. So if we have to find out the mass, mass must be equals to power times time divided by g times h. Let us substitute the values. The power is given as 156 watt. This work is being done in 11 seconds. Gravity must be 9.8 and height up to which it is raised, it is again 9.8. So you simply have to solve this and you get the mass. Ready to this?
Yeah.
So how much you're getting?
Wait. It works to 1,716. Oh, mass. Sorry. 17.9.
All right. So this is how you're supposed to solve power related problems as well. And these problems are there in your given thing only. Yeah. So let us talk about few things as well. So forces, whatever forces we have learned so far, they can also be categorized in two different quantities.
Mm-hmm.
And these two categories are based upon work. That is conservative force and another is non-conservative force. Like, let me just let you know this thing which is very important. When we talk about potential energy, the potential energy is also equals to negative of work done by conservative force. This is the definition of potential energy.
Mhm.
This is the definition of potential energy, that whenever we're talking about potential energy, it must be equals to negative of work done by that given conservative force. So we need to understand this fact that what is conservative force first and what is non-conservative force. So conservative forces are those forces because of which the work which is being done is independent of the path followed. So the forces due to which if work is done, no, if work is done, it is independent of the path. Like, what does it mean?
Mm.
So suppose there's a point A, there's a point B, and the force is acting in such a way that first took it from this particular path, second it took it from this particular path, third it took it from this particular path. So if the force acting on this body must be conservative force, then the work done here is independent of the path followed. So we can simply say that the work done when moving from the first path must be equals to the work done while moving along the second path, it must be equal to the work done along the third path.
Mhm.
This is what conservative forces are. Like, they doesn't care about what path is being chosen. What matters here is that whatever work is going to be done here, it should be done and there should be some displacement. Whereas if there is a non-conservative force, so it is not path dependent and path independent. So work done due to which, or you can say work done due to those forces which depends on path.
Mhm.
So here I can say that work done for all the given paths for the non-conservative forces must not be equal. So how many types of conservative and non-conservative forces do we have? Or you can say what are the examples? So here, the very first force, which is conservative force, is called gravitational force. Second type of conservative force is called spring force. Third type of conservative force is called electrostatic force or the Coulomb's force. The fourth force, which is conservative in nature, is called magnetic force. Now, what we need to understand here is, apart from these four forces, whatever type of force comes to your mind is non-conservative force.
Mhm.
Whatever force apart from these four forces are non-conservative force. For example, friction. For example, centripetal force.
Mhm.
For example, pseudo force. Like, whichever force comes to your mind. Viscous force, drag force, normal force, whichever force comes to your mind is going to be non-conservative force. Why we need to learn this? Because potential energy is also defined for these four forces. You will never talk about frictional potential energy, you will never talk about drag potential energy, you will never talk about normal potential energy. You will only talk about gravitational potential energy, spring potential energy, electrostatic potential energy, and magnetic potential energy. Because potential energy is defined for those forces which are conservative in nature. So
Right.
when we are talking about the potential energy, we initially talked about gravitational potential energy because gravitational force is a conservative force. So that's why we have gravitational potential energy as a one such potential energy. Similarly, in the coming class, we'll talk about spring potential energy. So in order to talk about spring potential energy, we need to learn about spring force a little. Then electrostatic force and magnetic force, if they are there in your syllabus, we'll talk about them. Otherwise, you can just keep it in your mind that conservative forces are those for which only we define potential energy. Apart from this, there is no potential energy defined for any other type of force. So this not only limits the topic because you have limited number of forces for which you're going to talk about potential energy. But apart from this, you need to understand this thing that whatever force you're going to observe here, this force needs to be conservative in order to have potential energy associated with it. Potential energy is only associated with those forces which are conservative in nature. If they are not conservative in nature, there must be some energy associated with it, but that is going to be kinetic energy, not potential energy. So this is the most important part about this particular section, that is potential energy and kinetic energy. Although in the next class, we'll talk about different forms of potential energy. We'll derive what are the formulas we obtain for each of them. We'll also talk about how these forces actually acts on a body to do some work. So this is going to be the topic we'll go over in the next class.
All right.
As of now, let us just keep it till here only. Make sure you try all the assignments you have, not the one which you shared just today.